Hello, everyone. Welcome. For a change, it actually feels good to be back on stage versus sitting in front of the laptop and recording these sessions the last year. More importantly, appreciate all of you being in person this year and coming to the session today. My name is Arti Raju, and joining me today is my partner in crime, Schneider.
Nice to meet all of you.
Schneider and I have been working with customers like you in your migration journey to the cloud. And what we wanted to do today is, as you think about your migration, especially for customers that are running VMware workloads on premises, and you're thinking about, what am I going to do, like, if I want to migrate? We're going to be talking about VMware Cloud on AWS as a service, how you can utilize the service for your migration needs. The service has been generally available for a few years now, but we've done a lot of service enhancements in the last year. The session is also my annual session where I come and talk about updates to the service itself. So we'll talk about some of the enhancements that we've done to the service that you can utilize as you think about your migration needs. And the last favorite one is we also just announced a couple of weeks back VMware Cloud on AWS Outpost. And we'll talk about how you can use VMware Cloud on AWS Outpost as you think about modernizing your on-premises environment. We've seen a number of business drivers that we hear from you on what are the reasons to migrate to the cloud, whether that's starting with data center extension or mergers and acquisitions that your company has. Whatever that business driver is, once you've figured what that driver is, as we sit down, as solutions architects, we sit down with customers and we ask them like, hey, we know you want to migrate. Like, we ask them a lot of questions. In return, they do ask us a lot of questions. How do I get started? What should I be looking at? Which application should I be looking at first? So we want to answer all these questions. But of course, you heard from Adam this morning if you attended the keynote. One size doesn't fit all. I'm going to rephrase it. One architecture is not going to fit everybody. There's going to be different architecture patterns that we're going to be talking throughout the session. And we'll answer these questions as we go. We'll start with a quick insight into the service itself. And we've been working with a number of customers. I talked to a couple of you before the session started on what are some of the use cases that you're looking as you think about migrations. And majority of our customers start with cloud migrations. Cloud migrations could be something as simple as, hey, I want to migrate a specific application to the cloud, or I want to completely do an infrastructure refresh. My hardware is getting old, and the cost that the spend on my hardware is increasing, and I want to migrate to the cloud. We also have the data center extension. As you think about expanding into a new geographic region that you may not have a presence in, or some of the seasonal capacity where you just want to add additional capacity for a short period, those capacity bursts, we look at those under data center extension. Disaster recovery, this is absolutely important. We think about, we want to architect for failure. That's the ultimate goal. No matter what happens, we want the application to be available. And when we launched the service, this was like our most popular use case. We started the service, everybody started using it for DR purposes, and a number of customers then migrated their DR as their primary site. And this could also be building new DR sites or replacing existing on-premises DR sites. The last use case is something we've been seeing more recently is around the modernization. As you prepare for migrations, can I utilize the same time to modernize some of my applications so I can utilize the native AWS services that are available? We'll talk about these as we go. As you see here, we've seen multiple customers, William Hill, PennyMac, Brinks, S&P Global. I've been working with some of these customers very closely, and they fit into not just one bucket of use case. They fit into multiple buckets of use cases that you see here. Just taking a quick peek at the service itself. It's built on top of the AWS global infrastructure. I'm sure many of you are familiar with these building blocks here, vSAN, vCenter, NSX, vSAN, vSphere. What we did is we took all these building blocks that you probably are familiar already and packaged it into a solution that we call the Software-Defined Data Center, SDDC. This is packaged and it's running on AWS Global Infrastructure. So what that means to you is you go in API or through the console, a click of a button, you deploy the software-defined data center depending on the capacity you need. We also want to make sure you're running VMware workloads on premises. We want to make sure you have the same operational consistency between your on-premises and what you're running here. So we've built that into the service to provide you that single pane of glass between your on-premises environment and your VMware workloads you're running on AWS. What this also enables you to do is utilize the same tooling that you use on premises. It could be your vRealize suite of products or your PowerCLI scripts, et cetera. And as we talk, the final stage is like, hey, I'm already on top of AWS Global Infrastructure. You guys have, we have around 200, probably more services based on the keynote today, but we've got a number of services that are available. Can we utilize some of these services? Because now both my SDDC and my AWS services are within the same infrastructure. And yes, as we built the service, we also made some integrations possible that enable you to take advantage of the native AWS services. We built it purposely this way, to take off some of that heavy lifting off of your plate. So if you look at what your teams might be doing today on premises, they take care of the data, they take care of the application and the operating system itself, but they also take care of the hypervisor, they take care of storage, patching, cooling, et cetera. So this is what we wanted to take off of your plate and said, hey, we'll manage this. We'll manage it as a service where you can now spend time on your data and application and spend less time on managing these abstracted layers you see here. What this gives you is that flexibility to have the same consistency of your workloads on both sides. You can also, given you're running both VMware workloads on both sides, it's not nested virtualization, you're just running ESXi directly on our bare metal host. You can now migrate workloads, just not from on-premises to the cloud, both ways that workload portability is available. You also get access to the native AWS services that can enable you in your modernization journey. The service today is available in 19 regions. We just announced Osaka a couple of weeks back, and our goal is to make it feature parity with the AWS regions that are available as well. I wanted to focus the rest of the discussion on 4 major areas. The core of today is migration. So we'll talk about how you can do migrations at scale. What should you be thinking of as you prepare for migrations? How do you think about backup and your disaster recovery strategy? And how do you think about, like, what services can I use? Like, can I use native AWS storage services that are available? Can I offload some of my databases into native AWS services? And then finally, while doing all of this, keeping security in mind as you do all of this. One of the most common questions we get asked when we sit down to talk about migration options is, hey, am I going to have downtime? What are my options that are available to me? Depending on your application, mission-critical application versus dev test application, you tell us what your applications are and how you want to migrate. And we've got a couple of options for you. The service, VMware Cloud on AWS, has built-in hybrid cloud extension. This is included as part of the service. I like the music. You guys can enjoy the music in the background. It's included as part of the service. What it means is it basically provides you that interconnect between your on-premises environment and VMware Cloud on AWS. You set up your HCX between both these sites, and now you select what VMs you do want to migrate from your on-premises into AWS. The cool thing about HCX is you don't pay any additional cost, but apart from a cost perspective, you can also migrate older versions of vSphere that you're running on premises into VMware Cloud on AWS. Of course, I think anytime we talk about migrations, performance is key, and the service has built-in dedupe and compression that can help you with performance. We announced a couple of key features into HCX this year that is primarily focused from a performance perspective. I'll spend a few minutes talking about a couple of these. The first one is the replication-assisted vMotion. So this uses the VMware replication technology and vMotion. What it lets you do is it basically allows you to specify a switchover window. You select your VMs, you specify a switchover cutoff window, and you schedule your migrations. The next one is your mobility-optimized networking. Prior to this feature, when you have extended networks between both sides, your on-premises and VMware Cloud on AWS, and you're migrating a VM from your on-premises into VMware Cloud on AWS, the traffic would hairpin back to your on-premises when there's a north-south traffic going outside to hairpin back to your on-premises. With mobility optimized networking enabled, you now can use the cloud-side gateway for that traffic going out to avoid that hairpinning. The next is application path resiliency. As you can see here, you've got two sites here. There's a lot of traffic flowing. There's interconnect traffic. There's also your HCX traffic. Your VM traffic could be flowing. What application path resiliency does is it optimizes by creating multiple tunnels and choosing which tunnel is best for what traffic. And then finally, we've got the TCP flow conditioning. This is a performance optimization that adjusts your segment size so that you don't have to suffer any packet loss or fragmentation. As you saw, networking becomes a key when we talk about migrations. It is important to understand how to set up your networking properly so that you can have a smooth migration. Drilling down into the networking piece a bit here. You've got your on-premises environment on the left. You have your AWS cloud, where VMware Cloud on AWS sits on the right. On the right side, if you focus, you've got your compute gateway for all traffic to your compute networks, and you've got your management gateway for all your management VM traffic, front-ended by an NSX edge. This is like the basic architecture. You're going to be seeing this architecture throughout this session, so I'm spending some time on this slide here. From a connectivity perspective, we recommend customers to use AWS Direct Connect. It gives you 1 gig, 10 gig, or you can use a link aggregation. Gives you that consistent bandwidth, low latency, and a dedicated connection for you for that migration. So you create a private virtual interface. Think of it as a VLAN between your on-premises and the AWS colocation. So now you have a consistent path, networking path, between your on-premises and your VMware Cloud on AWS. So for migrations, or even if you have extended networks between both these environments, you have a stable connectivity available. We want to talk about scale. Customers have told us what the previous diagram that we showed, one SDDC connectivity using Direct Connect works great. But we're building for scale, and we have multiple SDDCs that we are going to be having. How can we connect multiple SDDCs back to our on-premises, or like have multiple SDDCs communicate with each other? So we introduced VMware Transit Connect. This is based off the AWS Transit Gateway. So the AWS Transit Gateway is a service that AWS manages. Think of it as a central hub where you can attach spokes to it, and these spokes in this case could be your SDDCs. You attach these spokes to the VMware Transit Connect. What this now provides you is it's a virtual router that allows connectivity between your SDDCs. So now your SDDC 1 can communicate to SDDC 2. Prior to VMware Transit Connect, we had to rely on layer 3 VPN connections to communicate between these SDDCs. I've managed VPN connections in the past. It's not fun. I'm sure you'll agree. But this eliminates all that. All you have to do is attach your SDDC into the VMware Transit Connect. What it also allows you, as we think about modernization, is you can attach, as you're running workloads within your virtual private cloud on your AWS environment, you can attach the VPCs into this Transit Connect as well. Now, what you have is a centralized hub, and you have multiple spokes now that can talk to each other. So your workloads running in SDDC 1 can communicate to the VPC. And then we build out our network back to our on-premises using a Direct Connect. In this case, we're going to be using a Transit Virtual Interface, because whenever you use a Transit Gateway, which the VMware Transit Connect is, you'll be using a Transit Virtual Interface. As we take a deeper look into the transit virtual interface architecture, as I said, the diagram remains the same. We've got our on-premises. I have a region with the VMware Cloud on AWS environment. I've attached my SDDC to the Transit Connect. I create a Direct Connect gateway. I attach my Transit Connect. And I have communication flowing between both sides. A new feature that we launched with this architecture is customers said, hey, I've got an NSX Edge that you see here. Works great, but what if I need more bandwidth? The NSX Edge can do up to a certain level of bandwidth. What if I need more bandwidth for my north-south traffic, for example? So we introduced the multi-edge SDDC feature that allows you to have additional NSX Edge, and you can optimize your traffic using policies and traffic groups. As you think about scaling from one region to another, and this could be applications for disaster recovery use cases, or you're having applications running geographically in different locations, the same principle applies. As you see, I've changed the diagram now to have two regions. We've got SDDC connected to a transit gateway, Transit Connect in a region. We've got that connected all the way back to on-premises. Same thing, on the region B, I have the same architecture. You can use the same Direct Connect gateway. It's a global object. You can use the same Direct Connect gateway, connect it back to your on-premises. What we've also done is, how do I have my SDDCs between regions, like region A and region B talk to each other? I don't want it to go all the way back to my on-premises and come back. That's a lot of latency as well. So we introduced the peering feature between the Transit Connects. As you see that yellow line that came up, you can peer your Transit Connects across regions so that you have connectivity between your SDDCs. The other thing in this diagram is those VPCs that you see. You can attach as many VPCs to your Transit Connect to provide that communication between your VMware workloads and native AWS services. This is where it paves way to that modernization story that we talked about. The first step, we see customers taking multiple phases. First phase is obviously migrating your on-premises workload into VMware Cloud on AWS. But then thinking about the next phase is, what services can I use? I want to do backup. Can I back up to S3? Or can I use a file system, for example, or use RDS for databases? We've seen customers take different stages depending on where they are and what level of AWS infrastructure they have. We have customers like PennyMac, for example, that actually built a serverless platform. They migrated some of their VDI workloads into VMware Cloud on AWS. And then they built a serverless platform for a different application that still needs to communicate using AWS Lambda. So depending on which phase you are in, you can figure out what services can you use. Going back to one of the questions, what are you trying to build? Like, what do you want to solve for? And then picking what service you want. And you don't have to worry about these integrations. These are already built into the service. I did mention anything that we do, we want to make sure we keep security as our top priority in mind. We launched a couple of new features this last year. The first one is the advanced firewall capability with NSX that provides you that layer 7 IDS, IPS capabilities to protect against vulnerabilities in your SDDC. We also announced the PCI compliance. You can now run workloads that require PCI compliance on your VMware Cloud on AWS SDDC. This is available in 13 regions, so we are slowly expanding it to the other regions as well. And finally, very recent announcement is for our US public sector customers. We did announce the FedRAMP High level agency authority to operate for their workloads. As we think about, we talked about migration and those networking capabilities, it's also key to plan for your backup and recovery, disaster recovery. Whatever your options are, you've got a couple of options that's available for you as part of the service. VMware Site Recovery Manager, which a number of our VMware customers are using on premises. We recently introduced VMware Cloud Disaster Recovery, which we'll quickly see in a minute. But there's also other options available. We've got a broad set of ISV partners, Veeam, for example, or Commvault. There's a number of partners that also help with backup and disaster recovery. The use cases that we see for this backup and disaster recovery spans across a couple of areas, either building new DR sites or replacing existing DR sites. Or as I said, I worked with a customer who said, hey, service is new, I'm just going to use it as a DR. They started using it as a DR. A DR event happened. They migrated, they used the VMware Cloud on AWS as their primary. Performance was great. They migrated that as their primary and kept their on-premises as DR. And then finally, we also see customers that are fully migrated on-premises into VMware Cloud on AWS, use another region, another SCDC in another region for DR purposes. And as we look into VMware Site Recovery, it's an end-to-end DR solution. You configure site recovery, you select which VMs you want to protect, and it works. The important thing with site recovery is it's delivered as a service, so you don't have to deploy virtual machines, et cetera. The other option that is available for you, which is a recent announcement, is the VMware Cloud Disaster Recovery. It's an on-demand solution, so from a cost perspective, it's much cheaper than Site Recovery Manager. But also, the architecture is fairly different. For VMware Cloud Disaster Recovery, we replicate to the cloud and recover when needed. I think that's the important point there. So from a recovery site perspective, you have two options. You can either leave it on demand if you don't have any strict RTO needs, or you can do a pilot light where you spin up a minimum number of nodes, keep it running, and when there's a disaster, use that. So that sums up some of the options. As I said, there's other ISV solutions that are available as well that you can utilize for backup and disaster recovery. With that, I will hand it off to Schneider to kick off VMware Cloud on AWS Outposts, just recently announced, and how you can use that in your on-premises environment today.
Thank you, Arthi, for taking us through all of that and helping us to understand how we can modernize, accelerate migration with VMware Cloud on AWS within the region. But why has it become necessary for us to extend or drive this modernization as well in the data centers that you operate as customers or partners? There are several reasons for this. You all agree with me that it is not all cloud workloads, or not all workloads, I should say, can operate in the cloud. As Arthi mentioned initially, not a single architecture fits everything. So there is a reason why some of our customers like yourselves and our partners are still running their applications on premises today, powered by vSphere. As we worked with you, our customers and partners, to understand your needs, we learned that there are some major reasons why customers like yourselves are still operating on premises today. Let's talk about some of these reasons here. Some of you customers told us that you process a lot of data locally on premises today. And so sending all this data over a network to the cloud can be wasteful. There could even be data integrity issues when the network connectivity is not even reliable. And for that reason, you are compelled to still continue processing this data on your vSphere infrastructure on premises today. Another thing that we heard from some of our customers is low latency requirements. Some of our customers, like yourselves, are running very latency sensitive applications that require sub-millisecond latency to dependencies on premises. And for that reason, you agree with me that if you would migrate that application to the region, it is rather going to increase the latency. So it is not going to be viable for those applications. Also, customers like yourself, some of you operate around certain compliance requirements that demands that the data as well as the infrastructure running your data should reside in a specific geographic region. This could be in a country, state, province, or even specifically within a specific building. So for these reasons, it is hard to think about migrating to the cloud, and you keep producing, or I should say running your infrastructure on premises, out of which the majority is vSphere workloads. And as AWS, we are very customer obsessed. We like to work with you customers to understand your needs in order to do something that addresses the pain points we have discussed. So we took this feedback and went back to the drawing board. And that is what led to the birth of the new service that Arthur mentioned, VMware Cloud on AWS Outposts. So what is VMware Cloud on AWS Outposts? If you hear this concept of outposts, I'd like you to think of it as an AWS service that brings the AWS infrastructure services, which includes VMware Cloud on AWS, as well as our cloud operating model to your own data center. That is what VMware Cloud on AWS Outpost is. And so how we do it is that it comes in the form of a logical construct that is used to pool capacity of compute and storage in the form of racks, so that you can integrate that with your on-premises networks and then consume the software-defined data center or your SDDC on these racks in your own data center, just like you would in the AWS region. So for those of you who haven't seen how it looks, this is how it looks. It is actually a rack that is fully assembled by AWS. We bring it into your data center or wherever you tell us to put it. And then we connect it to power and your network. We bring it online, and you are ready to now spin up your software-defined data center or VMware Cloud on AWS on these racks, which we call the logical outpost. And the interface, everything is the same as the vSphere or the VMware Cloud on AWS you know in the region. So here are some specifications in terms of the sizes and what is in the rack, right? Within the rack, we've got servers, which are hosts. We've got the network gear in there. We've also got patch panels in there. It is self-contained, and it's a very fully managed service that we bring in there. So once set up, you don't need to worry about what goes on in there. But now, I would like to take some time to talk about the compute that operates within this rack that you're looking at. Now, some of you customers are running your compute in the form of rack servers or blade servers or different servers with different type of form factors on premises today. And that is where you install vSphere to your bare metal instances. So with VMware Cloud on AWS, the service we are using, like you saw in that picture, is similar to a rack server, and we call it the i3en.metal. So this one is powered by the Amazon EC2 service. And this service comes with the Amazon Elastic Block Storage, and we use that as the storage for booting your vSphere only. But in addition to that, this rack server you see here has got non-volatile memory express SSD drives within. So what happens is that when we put the vSphere onto this bare metal, we use the VMware software-defined storage, which is the vSAN, to provision these disks into your data stores. So we provision part of it for caching and part of it for capacity. So out of the capacity, you can get up to 45.8 terabytes of usable storage out of the 50 terabytes raw storage from a single node. And there is plenty of CPU as well as memory capacity per node. So you realize here that if you cluster a number of these within a single outpost rack, is plenty of capacity for you to consume on premises as a fully managed service of the SDDC that you can get within our region. We bring this closer to you. So with this in mind, since this is a new service, I'd like to talk about the configuration options that is available for customers like yourselves to order today if you're interested in using some of these services for yourself. So let's talk about that. In terms of the configurations, the minimum requirements of nodes, or these i3 EN metals, that you can run within a single rack is 3 nodes. However, the entry-level amount of nodes that we provide that customers can order for is 6 nodes. And then you can increase that capacity up to 8 nodes per single rack. Additionally, we also offer granular configurations such as the 4-node or the 5-node or the 7-node option as well. But unique to VMware Cloud on AWS Outpost, if you select any of these capacities, it comes with something called the dark capacity. So the dark capacity is a few extra nodes that we put in there for purposes of remediation or lifecycle management. That's the reason why we put that in there, because think about it. This is not operating within our own regions, and so when we have a degraded hardware, we are not able to attend to it very quickly. So we have some spare capacity in there for you as customers, so that if something goes wrong from the hardware perspective, we are able to bring that dark capacity online until someone gets in there to address the situation. So these are the configuration options available for customers and partners like yourselves if you want to use this service of the SDDC in your own data center. But now let's talk about how this technology works. Now, if some of you here have already played a little bit with AWS and our services, you know that on AWS we have this concept called a region, which is a geographic location where we operate our availability zones, and these availability zones are data centers that are connected to one another. Now, if you want to consume any service on top of AWS today, you use something called the Virtual Private Cloud, or the VPC. This is a segregated section out of the AWS cloud from the networking perspective for your own environment, so you can put your services in there. So within the availability zone, we do have the Outpost service. It runs as a service. And if you choose to order for one, that service connects to your own virtual private cloud, so you can use it privately. But then this diagram you see here, it's in the region. How are we able to bring this closer to your own data center? We do this by extending the capabilities of this VPC you see there to your data center or wherever you tell us to put that rack. And we deploy the Outpost rack and its components into that extended VPC you're seeing there. So the way we get this VPC to operate in an extended fashion is through something we call the service link. We use this service link to connect this Outpost back to the Outpost service in the parent region. So just like you can see here, this Outpost is not designed to operate as a rack independent of the AWS region. It is actually part of the AWS cloud that we bring closer to you, service link, so you can consume your software-defined data center. You can think of it as an extension of our availability closer to your own data center. And with this, you can now address the use case of having local data processing requirements or data residency requirements or low latency requirements. But now that we've spoken about how this works, let's now talk about the connectivity options here. Because I did talk to you initially that this is engineered in a way that we bring it to your on-premises and it's supposed to interact with the workloads you have or the networks you have on premises. So how do we do this? From this logical diagram you see here, the left side is the Outpost, and then the other side is your on-premises environment. So what we do is that as a customer or a partner, you would have your own core switch or core router on premises that connects your environment. And within the Outpost rack, we have something called the Outpost Networking Device, or OND for short. These network devices is what we use to connect between yours. So what we do is that we create two link aggregation groups using link aggregation protocol to do this. And then what we do is that the links between, or the links that we put in these link aggregations are aggregated together as a single network between your network devices as well as the outpost that you see right there. On the SDDC today, it is powered from the networking perspective by the VMware software-defined networking called NSX. That is what you use to create your logical networks on the SDDC so you can connect your virtual machines to these. The same applies on the outpost. The NSX components are there, but you don't require NSX on premises to interact with it. What we have done is that you can see that on the outpost, we have a new routing construct called the LGW, which stands for Local Gateway. What this local gateway does is that it advertises the networks that you create on the outpost for your virtual machines towards your on-premises environment and vice versa, using BGP sessions in the form of virtual interfaces. And that is what allows your on-premises networks to communicate with the workloads that you put on VMware Cloud on AWS Outpost. This integrates with HCX so you can do normal vMotion. You can also use HCX to migrate between your on-premises and this Outpost construct as well. But now that we've spoken about how we connect this to your local networks, I'd like to talk about some networking options here. Some customers like yourselves use this Outpost, and they have more than one of these on premises today. And we have discussed that every single Outpost is an extension of the virtual private cloud from the region to your on-premises. Now we have use cases. We see customers wanting to have network connectivity between these two racks. How do you do that? Like we saw in the previous slide, each of these outposts have connectivity to your own networking environment. So from the routing perspective, all you have to do is to advertise the routes from each rack to the other and vice versa. And you can do the routing decisions from your own local network where you want your routes to go. But what is unique about this architecture? For those of you customers who have requirements for local data residency requirements, like data shouldn't come out of that outpost to the region, this architecture would allow you to route traffic between two racks without sending the data back to the region, without tromboning back to the region and coming back to the rack. So if you have that specific use case and you have multiple racks or multiple outposts, this is what you can use. This architecture will help you to communicate or route between these outpost devices without getting back to the region. Let's talk about another scenario here. Besides doing it through your on-premises, Arthi spoke of the VMware Transit Connect construct, which runs in the AWS region. So today, just like you create SDDC groups in the region and put an SDDC within that group, you can do the same with outposts. When you do that, it attaches itself to the Transit Connect that operates from the parent region. And so this is how the routing will look between the two. But you notice that these routes are going to go all the way into the region through that Transit Connect before it comes back to the other one. So if this rack is located somewhere very far away from the parent region, you can expect to see some latencies there. But why would customers do this? Some customers are using this architecture as a backup to what they have on premises. In case that goes down, they can still communicate between the racks. Others are using it to communicate with other constructs. But like you can see here, if you have the requirements for data residency, this architecture here is not the best idea for you, because data would go into the region before it gets back to the other one. So this is an option available for customers who have unique use cases around having a backup without worrying about sending data back to the region. Let's talk about another scenario. We also see customers today who have outposts, but they might want to burst their capacity into the cloud. Again, they can, with a few clicks, they can set up an SDDC in the region, not on an outpost. And then they can create an SDDC group which brings up this VMware Transit Connect and attaches both to this. And in that way, they can also communicate between the SDDC in the region as well as the outposts they have on premises, and even integrate to their on-premises networks as well. Again, I'd like to highlight that with this architecture, for customers who have requirements not to send data out of where the outpost is located, this is not going to work for you because data would always go back to the region. So if you have requirements for data residency, the first option that I discussed is the option that works. But if you don't have that requirement, these are the connectivity models or options available for you to use if you want to use this specific service by extending the capabilities of your compute into the region by using another one. Now, customers use these architectures, for instance, if they also want to do disaster recovery into the region. Some use this. So these are the connectivity options available today if you are using VMware Cloud on AWS Outposts. So now we have discussed about connectivity, how it all looks when you connect on premises. But now let's go back to modernization. How can you drive the modernization on premises today with this service we discussed? Let's talk about how you can do modernization with disaster recovery. Arthi has given us just an introduction of how we can do disaster recovery in the region with VMware Cloud on AWS. But I would like us to talk about a scenario here. This was actually one customer use case. The customer had an environment which is a vSphere environment in the east coast of Canada, actually in Montreal. And they had requirements to do failover into the cloud. But the disaster recovery strategy demanded that the failover or the recovery data center had to be in Western Canada, where we didn't have AWS region over there. And they also had requirements not to fail over into United States. And these customers are running vSphere on premises. So what would they do? This is where VMware Cloud on AWS can help address the situation. Because remember what it is? It is an extension of the cloud or the SDDC from the region to wherever you tell us to put it. So the solution here, you can have an outpost in Western Canada that connects to a parent region anywhere you want it to, in the US or somewhere else in Canada. And then the customer had the option of using their own site recovery manager on premises between both environments. They just had to establish connectivity and then deploy the SRM components and then start their vSphere replication between the sites. And so in this way, they got the East Coast to become the protected site, and that outpost in Western Canada is going to become the recovery site for them. In a disaster, they can fail over to a fully managed cloud environment in a small data center somewhere that can house a 42U rack. And that is how they have designed their disaster recovery strategy. So this helps you to see that you can modernize by implementing disaster recovery even in places where we do not have AWS regions for your vSphere workloads. And again, it is the same environment, the same user interface, consistency. Nothing changes here. So this is one option for modernization from the disaster recovery perspective. Also, we can have customers who also have an outpost on premises today, and they also want to do disaster recovery from the on-premises to the region. Again, with a few clicks, they can set up VMware Cloud on AWS in the region, and they can build connectivity between the two, which is the on-premises and VMware Cloud on AWS, either through Direct Connect or a normal IPsec VPN tunnel. With this established, the customers can now use Site Recovery Manager, which is the managed one, not the one you have on premises, but this is the fully managed Site Recovery Manager service on VMware Cloud on AWS. You just need to deploy the components and pair both environments together, and then you can replicate your virtual machines bidirectionally. And when there is a disaster and the outpost is not operational, you can recover in the cloud, and vice versa. So this is one option that is available today. We also have another use case where customers could have more than one outpost in two different sites, and they still want to implement disaster recovery. Again, what can happen here is the customers just need connectivity between the two sites, and using the self-managed Site Recovery Manager, you can deploy the components across both of your outposts and configure the pairing and get the replication done between the outposts. So you can see from this perspective that there is a lot you can do when it comes to disaster recovery with VMware Cloud on AWS Outposts. It allows you to modernize your disaster recovery strategies so that you can scale yourselves in a way that this is a fully managed service where you don't need to worry about the infrastructure and how it operates and how it is managed. But now we have spoken about doing and driving this modernization with disaster recovery. How about the native services that Arthi discussed with us, such as storage services and other services? Now with VMware Cloud on AWS Outposts, we have certified 5 native AWS services that you modernize your environment with. And why 5 as opposed to 200 in the region, as Arthi explained? And I'll explain that to you shortly here. Now, if you have deployed a software-defined data center in the region, what happens is that we always ask you to connect an AWS account to it. In that AWS account, there is what we call that VPC, and what we do is we connect that VPC to your SDDC. This path is what allows you to consume our native AWS services. We have maintained the same architecture for VMware Cloud on AWS Outpost. So if you want to use native services, you would run that native service from the connected VPC to complement the virtual machines that you have running on the outpost you see there. However, note that the distance between where that VPC is, if it's in the region, could be far from where you have that rack located. And so there could be latency between both environments. And this is the reason why we have certified 5 services that can work with this architecture to help you to integrate with our native services. As we continue to build and evolve this service, more services will be added to it so that you can continue to drive this modernization in your own data centers. So now let's talk about from the storage perspective. What storage service have we certified to use with this? You can use the S3. And with this S3, you can have endpoint services. And what that means is that the traffic that is going to go between this outpost and your VPC does not traverse the public internet. It all goes securely and privately through the AWS network backbone into your VPC, and you can offload your storage into S3, object storage. So for instance, for those of you using backups that integrates with S3, you can back up your VMware Cloud on AWS Outpost and use S3 as the repository. If you're running applications, you can also put your repositories in S3 and offload that storage that you have on VMware Cloud on AWS Outpost. So from the storage perspective, this is one way that you can modernize on VMware Cloud on AWS Outpost today. let's talk about monitoring. When it comes to monitoring, we also have the Amazon CloudWatch service. This service also allows you to monitor your environment just like you would use other services for monitoring purposes. And in the same way, through the same architecture, you are able to have this CloudWatch set up in your own VPC that is in the region, and it would use that service link connectivity we discussed and these cross-account elastic network interface connections to communicate with the Outpost rack. And you will be able to monitor your virtual machines through the agents that you deploy to them. So this is about monitoring. Let's also talk about systems management. In terms of systems management, you can also use AWS Systems Manager with the endpoint services that we have. And you can use that to manage. You can use that to patch your Windows as well as Linux workloads that are operating on the Outpost. These are all managed services that can modernize the way you do things on premises today to lift up the operational overheads so customers like yourselves can focus on what matters to you most. So as you can see, we also have the Route 53 Resolver service in there. That service is there. It's our DNS service, which is fully managed, and it also allows you to implement DNS, to use our DNS endpoints with these native services in your own VPC and integrate that to the DNS service that we have on the SDDC. So from the systems management perspective, this is what you can do. Finally, the last service I'd like to talk about is also the Active Directory service, the Managed AD service. So today, if you don't feel like operating your own AD in VMware Cloud on AWS Outpost on premises, you can choose to use our Managed AD service in that connected VPC to manage your environment. Or if you even want to extend the capabilities of your on-premises AD service onto VMware Cloud on AWS, you can do that and run that from the connected VPC as a directory service that is fully managed for your environment on premises. So like you can see, these are the services that are vetted to operate on VMware Cloud on AWS Outpost. However, in the region, I'd like to iterate that you have access to the 200 plus services that we have to complement with VMware Cloud on AWS. So this session or this side now wraps up the entire session today about how we can drive modernization in your own data centers. You can do this with VMware Cloud on AWS Outpost as a fully managed service. Now here are some resources that points to reference architectures as well as how to get started. You can take pictures of these so that you can go to these websites. And if you're interested, you can engage as well with your AWS Solutions Architect to help you to get started. So at this point, I'd like to thank all of you for taking time to come here. And we'll be hanging out back there. If you have any questions, please don't hesitate to come to us behind the hall after we complete today. And more importantly, do not forget to fill out the survey. It's very important. We like to hear your feedback. We like to hear how we can improve these sessions, what to include, and how to make it more enjoyable for you next time. So we look forward for your survey responses, and hopefully next year they would allow us to come here again. And I want to thank you all for your time today, and do have a lovely day today. Thank you.